So, good afternoon. Let's start. Welcome to our research seminar. Today the presentation will be given by Ekaterina Krekhovets, senior lecturer at the Department of Economic Theory and Econometrics, and Oleg Poldin, a research fellow at the Center for Institutional Studies. So you're welcome.
Thank you. Thank you very much for coming to this presentation. And I would like to present our research about student social networks in academics. And the title of presentation is Student Social Network of Friendship, Structure and Factors of Formation. And the structure of our presentation would be following. Firstly, I would like to introduce the motivation, why we choose this topic of research and which ideas were very interesting for us during our study. And then I'll briefly say about our research questions and what we examined and what models we use and so on. And then I pass on to data collections and some descriptive statistic analysis. And finally, I said some findings about students' friendship networks, about their structure, the key players in these networks. And then Oleg said about our econometrical estimations of factors of network formation among students. And at the end, some future prospects and future plans, and your questions and your opinions are very welcomed. So we hope to discuss maybe any ideas. It is frequently argued in literature that friends and peers have a large influence on how we behave, and in particular, this kind of peer effects are examined in literature which devoted to the problem of student behavior, and we know about some peer effects in education. And moreover, friendship is a very useful resource for students during their studying and after they finish in university. For example, students, friends usually help to each other in some home assignments or even in exam tests and so on. So the interesting question is how we choose our friends and how we are chosen by them. So are there any observable factors which affect friendship formation in university? And of course, our research was not the newest one, and there is a lot of literature devoted to this problem. And a lot of previous research in students' behavior and students' network consider that homophily is known to be one of the key factor of students' network formation and friendship formation. And homophily, it is a tendency for people to prefer ties with others who share their personal traits. So homophily can exist in different ways and can work in different ways. A lot of researchers examine homophily and in terms of race and ethnicity and in terms of gender. And also there is strong evidence that there is homophily effect in terms of socio-economic status, similar interests, taste of music and culture, and also students become friends if they share university activities. Another factor which are also named as essential is the geographic closeness, and this effect is also known as a propinquity mechanism. It is a situation when two geographically close students become friends. For example, if they have been assigned in one studying group or if they study in the same faculty, they are likely to be friends and they become more close to each other. And this effect also exists in case then students live in one dorm or in one room in the dorm. And the third crucial factor of friendship formation is transitivity. It's actually it's not in the focus of our today's topic, but I just say what this transitivity means. It's the property of ties in network. If there is a tie between A and B and one between B and C, then in transitive network C and A also be connected. So in terms of student social network, we can say that a friend of my friend is my friend. This is three factors which are usually mentioned in literature as key factors and key determinants of formation of links and friendships between students in university. Now I'd like to introduce our research questions. In this study, we pursue two main objects. Firstly, we try to analyze the structure of students' friendship network. For this, we use standard SNA characteristics, and we also try to detect any patterns in network. We try to examine whether is any particular structures in different network, in different faculties. Are there any key players in network, or all students take the same position, and so on. This was the first of our question. And the second one is to find the determinant and determinants which can affect the formation of students' friendship in the university. And here we try to implement some econometric approach to determine such kind of factors. And we examine hypotheses which are mentioned in literature according to homophily effect and geographic closeness effect. And for this we use our empirical data, which are the following. Our data were gathered from survey of first-year students from High School of Economics in Nizhny Novgorod, and there are three faculties in this survey: economics, management, and business informatics. And we also use some questionnaire. The students were asked to answer the questions about their socioeconomic status, about their friends in university, and we also use administrative data about their academic performance. In order to reproduce the network of friendship, they asked students questions about their friends. They asked them to point out the name of their classmates, which they regarded as a friend. And this is the descriptive statistics of our sample. Notably that mostly all students from faculties participated in this research. And here they represent four variables which are used as determinant of students' formation, students' network formation. First is average grade, and here we can see that average grade vary very slightly among all different faculties, and it's from 6.8 to 7.12, and it's not so not a very high variation, and mostly in the Faculty of Business Informatics, half of students are men and half of students are women, while in the Faculty of Management and Faculty of Economics, the distribution of gender is not so equal, and only 1/3 of students are men. According to ratio of living in dorm, they can see that only very few percentage of all respondents mentioned in the survey that they live in dorm, and the highest percentage is 21.8% in the Faculty of Management, but I should mention that these questions were self-estimated, and we can't maybe these results they differ from the real situation in university. And the last factor, the last characteristic is wealth. Here, this is a descriptive characteristic, and one was mean the lower income and 4 the highest income. So in average, students said that they have financial security and have a high income. And now I'd like to describe the network structure of friendship, and I start from the network of business informatics. And firstly, I comment on the picture. Different colors here means different study groups, and circles. As you can see, it's circles and diamonds. Circles is women, and diamonds are men. And the size of the marker depends on the in degree. That means how many classmates and how many students are choosing with one student as a friend. And this is a direct network, so it's possible to see who was chosen by whom, and who has a lot of friends, who not. And here there is some interesting result in this picture. We can see that there is a lot of links between students in one study group, and very few links between students in different groups. And one of the explanation of this situation is that this faculty, this group which are studied in this faculty, they studied in different campuses which are remote to each other. So students have no opportunity just to communicate to each other if they're in a different group. And in the table there is basic characteristics of structure of network. They can see that approximately all students will participate in this network. The number of students is 93, and the density of this network is 7%. It means that only 7% of all possible ties are realized here, and but this is a usual situation in the real network structures. And two essential characteristics which reflects the distance between students in the network is average distance and diameter. Average distance is shortest path between two students. In other words, two students need approximately 4 degree of links to communicate to each other, and the maximum chain it's diameter, the longest path between two notes between two students, it's 10 here. And one student in average has approximately 7 friends. It's average degree, and the clustering coefficient here is approximately 43%, which means that 43% of ties can be named as a cluster. So we try to create some strong triangles in the network. This is the Faculty of Management. The picture looks indifferent, and here you can see that there is a lot of ties between students in different groups, because always for this group they are studied together, they have the same lectures, they have the same subjects, so they communicate together, and there is a lot of ties between them. And all other characteristics which reflects the structure of the network of friendship, they looks very similar to the structure of Faculty of Business Informatics. There is also 7% the density, and approximately 7 friends in of one student. But we can see that students in this faculty, they are closer to each other than in the Faculty of Faculty of Business Economics, because the average distance and diameter is smaller, and maybe it's because of links between students in different groups, and their distance is closer to each other. And the Faculty of Economics, here you can see 5 study groups, and what is interesting here is that there is a free group, yellow, green, pink, and aqua, which are very close to each other. They have a lot of connections between these groups, and two other group, blue and yellow, which are connected in their small subgroup. And we can explain this kind of structure, that blue and yellow, this is a group of international economics, and 3 other group, they are just economics, and they have different subjects, they have different learning trajectory, so they have less opportunities to communicate between groups. And the characteristics of network seems to be very similar to previous cases. Also 7 friends, in average 7 friends of one student, and here they can see that there is a high clustering coefficient. It's more than a half. More than a half ties can be named clusters. And also we're interested in the in degree and down degree distribution, and the in degree distribution shows how many students, how many classmates mention one particular student as a friend. And here we can see that in all faculties the citations seem to be quite similar, and approximately from 3 to 7 students will mention one student as a classmate. And but we also can see that there is some very popular, some very powerful students who was mentioned by 11, 12, or 13 of his classmates, and we consider that these students are really popular in the society. And then we try to analyze why. And this is our degree distribution. It shows how many students one student detected as a friend, how many classmates he mentioned as a friend. Mostly all students in all faculties mentioned 7 friends, but here we also can see that approximately 10 and more % of participants said that they have no friends in the university at all. Yes.
May I ask just a small question? Whether in the questionnaire they had any restriction on the number of friends?
No,
Okay.
there is no
the
limit.
7 here is just occasionally happens.
Yes, because you can see that there is some students who mentioned 9, 10, and even 13. There is no limits in the list of friends. Yes, and we were very interested why students become so popular in their society, in their networks. And we have 2 observable factors. It's grade and gender, and they consider maybe a great influence the popularity in the network. Here we analyzed popularity in terms of centrality measures, and first one is in degree centrality, which means how many direct neighbors a node has. In terms of students, how many classmates mentioned with a student as a friend. Here they can see that there is no correlation, at least in the Faculty of Business Informatics and in the Faculty of Economics, no correlations between grade and in degree centrality. And in the Faculty of Management, they can see very insignificant correlation between these 2 variables. Popularity of students does not depend on grade. We can see. The second one is the Betweenness centrality. This measure shows the role of student as a bridge between other students in the network of friendship, and the students with highest Betweenness centrality, they act as a go-between, and they are very essential in their network because they share information in the network, and they are very useful. So there is also no correlations in all 3 faculties between centrality and grade. The last centrality measure was Closeness centrality. This measure shows how close the students to other students in the network, and this is also a very popular measure to analyze the access to information of the student and how influence this student in terms of sparing some information and some resources. And here we also can see that there is no correlation between grade and closeness centrality in business informatics and in the economics faculty.
Sorry, maybe I've missed it at the very beginning. What does it mean GPA here? Is it some average measure on all the courses at the end of the year?
Yes.
So it's the end of the year. But networks, but the data about network, it was gathered at the beginning, yes?
The grade here, the GPA here was measured at the end of a session. So firstly, the
first session.
First here, the first session, yes. So
session
they
is half of the year, or
yes,
first module?
they asked them to participate in survey in the October, and the results of grade was published in the December.
Okay, thank you.
Yes, students. Students didn't know about their marks, about their grades, but the average grades. But they know in the October when we asked them, they know about the academical performance and academical possibilities of each other. And here they can see that in the Faculty of Management also is insignificant correlation between between closeness, centrality, and grade, but in other faculties there is no such results. And we also try to analyze, okay, if grade does not play essential role in terms of popularity and powerful network, maybe gender is essential. And this table presents results of 5 students with highest centrality measures in 3 faculties, and we can see that average grade in 3 faculties, it's average and similar to the average grade in the whole sample, so there is no so highest results. And moreover, there is some students with low academic performance. And the percentage of women is in with more popular students. Only in the Faculty of Economics, all popular students are women in all centrality measures. Maybe it's because of the sample, because in the Faculty of Economics approximately 17% are women, so in the factor of homophily we try to communicate and try to become friends to each other, so they choose only women. And on the faculties of management and business informatics, we can see that the share of women and the men they differ from centrality measures. In different measures, the percentage of women are different. So the role of gender is a key factor of popularity, and powerful is under consideration and under the question. And now I'm going to pass on the presentation, and Oleg asked about factors.
Then we proceeded to estimation and model of friendship formation. We looked at so-called econometric approach, which is different from approach that is widespread in sociology, literature, in economic literature on networks. Still popular is a so-called dyadic level model. So we look only at dyads. It's pairs of students that are chosen randomly from the population. And look what factors may affect the probability of friendship formation between 2 randomly chosen students. So in our model, every student at any faculty may form a friendship with any other students from the same faculty. So no interfaculty ties are possible here. So we look at dependent variable, which is binary variable, which is 1 if student I nominates J as a friend, or 0 if I don't nominate J as a friend. So it's binary variable. Independent variables, they measure proximity of individual attributes. So we omitted any individual attributes. We can look only at dyadic variables. So they measure proximities. For binary attributes such as gender or sex, we call here sex. What else? Study group. We measure the proximity by indicator variable, which is 1 if students belong to have the same gender or study in the same group. And for continuous characteristics such as GPA or achievement level, we measure proximity by inverse distance. So we take the difference between GPAs, take absolute value and add minus sign. So the bigger the value, the bigger proximity. So data are dyadic, so the same student appears in many dyads. So in matrix notation, if we look at social ties matrix, each row corresponds to sender or student I, each column corresponds to receiver. Each student so have many ties and participates in many rows and columns. So because columns belong to the same students and rows belong to the same students, observations in individual rows and individual columns tend to be correlated because there are some unobserved characteristics. So these phenomena may have some unpleasant consequences for estimation procedure because we have non-independent observations. I mentioned two approaches how to handle this issue. First one is fixed effects, when we add some binary variables for each student in the pair, and so-called empirical standard errors that you use to test null hypothesis on absence of factor influence on friendship formation. There are some other approaches, for example, modeling correlated random errors that are correlated across observations, across columns or rows, but this approach is still under development, and in recent conference of American Economic Association, there was a paper on linear model on this modeling interdependence in connected ties. As for binary dependent variables, these approaches still are not developed. So we use only two approaches to deal with the problem of non-independent observations. As for fixed effect model, next to proximity variables, proximity between dyads, we add two fixed effects, one for sender and one for receiver. So we have different fixed effects for sender and receiver. So for each sender we have all set of variables corresponding to each individual, and for each receiver we have also the whole set of variables. In this model we have we consider two models: one linear probability model where f is just linear model, and f is non-linear function, it may be a non-linear function, and we consider the logistic regression model. Fixed effects, they cover all systematical individual level effects that may affect transformation. So there is no need to add some individual level attributes. They take on any such attributes. Unpleasant econometric situation here is that we have to add twice as many variables, dummy variables, as the number of students. So we may face so-called incidental parameter problem in nonlinear function regression, but this problem is mitigated in classical case of binary choice model in panel data, because the number of observations per student grows as network size grows. So the estimates of parameters, they are consistent here. Empirical standard errors approach, it based on the use of so-called quadratic assignment procedure, and its further development by Decker et al. They developed the approach was made famous due to work of Krekhovets, the project of Descriptive, so-called multiple regression quadratic assignment procedure. This approach has two main steps. I just depict on a basic idea because our QAP approach is slightly more difficult, but the basic idea is the same. The first step is just estimate the standard regression model, plain OLS estimates. And the second step involves estimation of standard errors of, in case of null hypothesis. The procedure is to make permutations of rows and columns of adjacency matrix. So just to preserve individual characteristic across columns and across. So only the variable that changes is dependent variable, which is a friendship status of friendship. So the second step involves three sub-steps, just preview dependent variable many times, which results in multiple random data sets. Then analyze these data sets and create empirical sampling distribution, whether of coefficients or some pivotal statistics. And finally, compare the observed coefficients from the original data set that we observed when actual friendship ties observed, and sampling distribution in case of randomly permutated data sets, where, of course, we don't expect that any factors will be significant. So that's why we test null hypothesis of null factors affect friendship. And then just we have empirical distribution, and we obtain p-value for null hypothesis for distribution of coefficients. So then we proceed to actual estimates. Here we present several models with dyadic attributes, same group, same sex, same dormitory, because students live in the same dormitory. We have only one dormitory in our campus, or they just live outside the dormitory. And GPA proximity with factors and several specifications. Linear probability model with standard errors, with empirical standard errors. Linear probability model with fixed effects. Logistic model, coefficients, it's hardly to interpret here as in other models. So please don't look at these coefficients. It's better to compare coefficients in linear model and marginal effects with logistic model. The fourth column is a logistic model with marginal effects. It corresponds to effects that are obtained in linear probability model and logistic model with fixed effects. So it's better to compare first two columns and the last columns. So we see here that despite there are some quantitative differences between estimates, the sign and order of estimates are approximately the same. They don't differ, but not in times. I will summarize some. So the strongest effect from the group, and the less profound effect is from sex, from the same sex and living in the same dorm. And the GPA proximity also matters here. And similar results for the faculty of management. The quantitative measures are slightly different, but we see that belonging to the same group is dominant factor in faculty of management as well, and in the faculty of economics as well. And in the final slides of empirical results, I present some interaction effects where we try to look at try to answer the question whether different homophilic factors they add to each other or they compete with each other. So the question of so-called whether multidimensional homophily exists. So first three columns is 0 if students in a diet don't have the same group, 1 if they have the same group, they study in the same group. Sex differs, sex the same. If one student lives in the dorm, other students don't live in the dorm, or both live in the dorm, or both live outside of a dorm. So we have the next column is probability of friendship if these factors are observed in actual data sets, p-value and confidence interval. So we see how probability of friendships increases or decreases if we have different factors in common. So if we don't have any factors in common, the probability is very small, it's not significantly differs from 0. And if all three factors of diet are in common, we have probability of more than 1/3. And 2 factors in common, less probability. And confidence intervals, they may hint on whether such differences are significant or not. For example, if we look at the last row, we see that confidence intervals are from 33%, and if we have only group and sex factors in common, the upper limit is 25%. So there's a significant difference between having these 2 factors in common and having these 3 factors in common. And the same observations may be made from the comparing other rows, for example, these 2 factors, these 3 factors, or this 1 factor with these 2 factors. Sometimes they differ, sometimes not. So shortly I summarize some findings from our presentation. So from maybe my part of presentation. So there are significant factors such as propinquity, which reflects the closeness in geographic measure such as study group or dormitory, and homophily with respect to sex or ability achievement measured by GPA. But study group effect is overwhelming and dominant. Additional similarity adds to the positive effect on friendship. And some words about our future development of this work. We plan to add psychological characteristics as to friendship formation and studying why some students are more popular than others, and maybe these and some significant measures to distinguish between why some students are popular and influence others, and in addition to grades, to sex, or what else. And we will try to closer look at interaction effects to see whether closeness in different factors adds to formation, or just being close one to another in one factor is enough, and any factors may be diverse, and this may be as well beneficial for having friends, for friendship formation, because literature tells us that there are different findings with this respect. And use econometric approach, which is more crude but more simple than more sensitive but more elaborate models such as exponential random graph models or classic actor models. this approach is more crude, but if we obtain some estimates, we may be sure that this effect exists and not such sensitive to specifications, and there are no issues with possible optimization issues such that are mentioned in literature on more complex models. So we hope that econometric approach, studying diets and whether they grow, how diets, connection between diets grows or diminishes with time. This approach is maybe also useful in studying dynamics. Thank you. Some
Any
questions?
questions?
Ready to answer the questions.
I have two questions. First is technical. In your dynamic regression, I says that J is his friend, right? Is it symmetric?
No,
So I claim you're my friend, but you might disagree with me.
as for results presented here,
Right.
results are for directed types. So
I understand
if,
that, but the question is, are they symmetric still? Because you have these couples twice in the sample, right? I claim you as my possible friend, and you could claim me as your possible friend. So my question is, to what extent this is symmetric or reciprocal, if you will?
as for do you mean statistics? How
Yeah, right. 90%,
what
80%.
proportion of ties is reciprocal?
Approximately 16 or 17%.
Mhm.
It's reciprocal.
Can you speak a bit louder because we cannot hear anything here?
Approximately 70% of ties are reciprocal. So, but
60-70%.
yes, but here we use direct ties.
Well, one reason I ask this question is that this reciprocity could be an estimation problem.
Yes.
You cannot really treat the observations ij and ji as, independent. You control for fixed effects, individual fixed effects, but I'm wondering if this is enough.
Actually, we have fixed
other words,
effect
the
for
probability
sender.
that I-
Sender. We distinguish between fixed effect for students who is a sender, who sends a tie
Right.
to nominate, and who receives nomination. So we have, for example, for students, say A, student A, or Vasya. As a receiver, he has one fixed effect, one dummy variable, and when he enters the equation as a receiver, he has another
Okay, well,
dummy variable.
I think
So I
that,
think that this distinguish is
Right.
called two-way fixed effects, and this can capture. But as for qualitative findings, they are the same if we consider only reciprocal ties, or we treat any connection, any directed connection as a reciprocal, just look at indirected ties. Quantitative estimates differ, but qualitative effects, they are similar. I mean signs and significance.
well, and then the second question is, did you observe any correlation between academic performance and the number of friends or the structure of the network, and if so, what it is, and what is the causality? Is it true that,
Correlation between
if a student is a high achiever, would she have more friends or less friends?
Yes.
And if so, is it because high achievers attract more friends, or because more friends help you to achieve higher scores?
We observed the correlation between in-degree centrality, which of course measures the number of friends, and the grade. And I showed these pictures. This degree centrality, in-degree centrality, and grade. There is no correlation, only in the faculty of management, but it's insignificant correlations here. And we can say that if a person have a good grade and he is academically successful, he have a lot of friends, or vice versa. But maybe it's not enough statistics, it's not enough observations here, and we have another samples, and we try to do the same operation.
One more question, if I may. Do you have any information on how intensive are the ties? I mean, friendship could be different, right? We see each other once a month, or we see each other every day and cannot live without each other. Do you have any measures of this intensity of friendship?
There is no characteristic to measure this kind of different kind of friendship. We just asked them to point the names of students of classmates with whom they are friends, and that's all.
Maybe some hints from studying of.
Well, I'm trying to see if there is any evidence of what is known as claim for weak ties. Sometimes people claim that's very good to have a large number of people who communicate regularly, but not particularly intensely, and that's better than having a small group of friends with which you're very tightly connected. So I'm trying to find out if there is any evidence here that this is also true. Because it's a well-known phenomenon. It's a solid.
So connection between popularity and achievements, at the average level, if we look at the students who study well, they have friends, usually friends have friends who also study well, and less successful students have friendship ties with less successful students. So there's some clinical segregation effects. So this popularity, because these students are connected, but not so much ties between good achievement students, high achievement students and low achievement students. It's a different kind of population. Popularity among good students and popularity among average students.
Thank you for your presentation. As I understood, you carried out a survey for this research question, right? It was not a database you got from somebody else?
No, it's not.
Okay, so then the question is, why did you choose the first year students? First semester, first
We choose these students because we thought that they are not, they have not been friends before the university, and then they came. They have some opportunity to become friends, and it was interesting to analyze which factors influence to the fact that they started to be friends or not. Because before they didn't know each other. That's why we use the first year students data.
Well, maybe it's not always the case that they don't know each other.
Actually, they asked them to mention classmates if they were studied before or if we were know each other before the university. And there is a very small proportion of such kind of students who were known together before the study.
Thank you for your presentation. It was very interesting. I have a small question about the measure of integrate centrality. On these graphics, you have integrate centrality from 0 to 0.4, and it is continuous, not discrete. But as far as I know, the integrate centrality should be discrete measure.
No, if it's normalized in degree centrality, it's...
You normalized it?
Yes, we normalized it to the size of the network. Yes, that's why it's not discrete. Because in these three networks, the number of students are different.
And I have another question about the GPA. You calculated the GPA for the first module, or for the second school?
We use the rating of students from the first session.
From first
So
session?
GPA in December and networks in October?
Yes.
First module is not average, maybe one grade or maybe no grades.
No, very
Trying to measure here just some achievement level in general, maybe kind of proxy for aptitude, which is better measured if we look at the whole year, or not just trying to obtain estimates how known information on grades affects friendships, but to just have it measured, obtained independently on friendships.
And you didn't take into consideration the unified state examination. You didn't take into consideration the unified state examination.
No, actually I did some preparations. Effects of unified state examination exists, but it's very small and sometimes insignificant. As for GPA, this effect is significant in all specifications.
Am I right that you used different models to predict the same thing, the probability of a tie?
Yes.
So what was the idea of using different models, especially if they produce different results? Because like you had some homophily on GPA, and in some model it was not as the others one. Why you didn't choose just one model that you think
Do you mean
better
why we use
predicts?
the different specifications?
Yes, like
With respect to this slide, to this kind of slide.
like for example,
Yes.
GPA proximity is negative at the third model, yes, and all the others is positive. How you explain this? And if you have such kind of different results, maybe it was better to choose just one model, and or it's just a mistake.
Sorry. It's my fault.
It's a small mistake. Okay, sorry.
Just ran regressions for distance and then deleted minus signs, and I think that this is because
It's positive.
It's positive. Yes.
because
Okay.
this column was inserted in the
Okay.
end just to add estimate. Just to add estimate.
Okay, let's.
Yeah,
So
because
we,
original one is this one, and just go to delete minus sign. You are very
so if it's positive,
It's
but
the-
we still predict the probability of a tie, and we use different types of models, yes, and we see that most of they are all produce pretty the same results.
Yes.
So, but why you used several models? Why not just to choose one that you think is like better, like tries to predict such kind of?
because every model has its own pros and cons. As for
Yes.
linear models, they are, for example, well suited for estimating fixed effects. As for fixed effects with nonlinear models, there are some issues, coincidental parameters, and nonlinearity adds some effects such as interactions between variables, even if we don't consider interaction term directly. So, but it's kind of common knowledge that if we look at linear probability model and marginal effects in a logistic model or probit model, they both models give correct predictions about the size of the effect. As for quadratic assignment procedure, it's just another way looking at correlation and testing hypothesis on possible effect of correlations, but estimated not with fixed effects, but with unknown structure of correlations. Just fixing issue with correlations. Just to see whether results are robust or not.
Whether it gets robust. Okay, thank you. Okay, I have then also a small question about, so in description of the data you presented some information about the wealth of students' family, and but you didn't mention it in your results. Whether it means that you didn't find any significant results, or it was just used for description of data?
It was insignificant.
Okay.
The effect of proximity in self-reported wealth status, socioeconomic status, sometimes they are significant, sometimes not. So in the final presentation, we omitted this variable.
I think you can use
Because
full family because you can use the status of full family, full and non-full, because I've
Okay.
noticed that it's a better prediction of the wealth of students in this data.
I don't know, it depends. But, complete family. Sometimes, I don't know.
Yes, there are some correlations.
For example, part of this for the children, they may afford to support the children. I know some facts when I worked in admission committee, some mothers, they come to, so the fathers, they are ready to pay for courses, or mandatory courses, for such things, for private lessons. It depends. But possibly if we have such information, we may consider it.
No, we have such kind of information. We asked about full family. We have this information.
In the first
Yes.
survey, yes.
Thank you. Thank you. That's very useful.
Okay.
I was just thinking whether you have seen other factors that may influence also the friendship in the network. Have you seen how the country of origin or city of origin affected the level of friendship?
Actually, here we didn't ask students to mention the region or the city of origins, but in the next survey, which we have in this year, they ask this question and we have some information, but we just
No, we have
about the region of students, where from which region and which city they are.
No,
Maybe
actually we
it's-
have this data. It's administrative data, and I look at these results, but they are not stable. Like there's no high correlation. I mean, there's no homophily if we are both from this city or other city.
And here
It doesn't predict.
in
Like
Nizhny
it depends on
Novgorod,
conditions.
in Nizhny Novgorod, a lot of students from Nizhny Novgorod and Nizhgorodской области, and very, very few students from other regions. So
Okay, let's
the
say
proportion.
two people are coming from Dagestan. And, can you predict the level of friendship?
but
I can predict. You know?
yeah, I see. But maybe they the friends before coming to university.
Well, not at all. So,
Yeah, it's interesting characteristic, and mention it.
if possible, also the second question about the literature review. Can you just briefly comment on your on the previous research that was made, maybe somewhere in Europe and States that would probably follow?
Okay. According to factors of network formation, all these researches which I mentioned here, they considered the students' network formation and students' friendship in university, and maybe I don't understand your question. Can you repeat? But it is
Just I thought probably someone in the past have also checked the same independent variables like you
all
did
of
that.
all of them.
Yeah, sure.
Yeah, that's what. Just I haven't heard about that, so probably I came late. So maybe thought about that.
One of the previous research where you can find the same topic is Valeeva, Yutkevich and Poldin, and that there is a lot of same research questions there, and but the model which were used in that research and the model which we use are some different.
Thank you.
I also wanted to ask you about the community detection stuff, because over there you just mentioned that there are different community structures for different friendship networks of the faculties. For example, in management, we have very dense networks without concrete communities, but for business informatics and economics, you could distinguish different groups.
Yes.
Did you calculate the different measurements of modularity and maybe other indices that can show the goodness of community detection?
Actually, we didn't calculate any other measures. We just calculated these basic characteristics, and we have some assignments about the structure of student friendship in different faculties, because there are some institutional possibilities.
I think it can also be interesting to study the different community structures within different faculties, taking into account the context.
Thank you.
As far as I understand, you approach the same students later in the second part of the year, right? It's basically the same questions.
Yes.
So I would suggest that you do the same exercise with another set of data, say for spring data, and check whether your results are robust in terms of whether you get the same estimation results. Because if you do, that's very good. If you don't, there's a question why. Because my problem with this data is just it's very kind of unstable data, because it's students which are new to the environment, they just get friends, that's quick friends, you don't know how stable this friendship is. You also don't know why students got these results during the first months of the year. Some students came from the strong school, they just know everything. Some students came from the weak environment. We don't know whether these results are exact results of efforts of those students or just the background. So I would suggest that you repeat the calculation and see if there is any dynamics.
Yes.
And if the dynamics actually exist, there will be another question why and what determines this dynamics, which is also even more interesting to look at.
Yes, thank you. This is what we are going to do actually in our research.
Is it possible to add some new questions in your questionnaire, for instance, about interests or character traits? Because maybe about character traits or interests of the students. Because maybe, as you said, on the first period, such factors as the same groups and gender are very important, and then they are replaced by same interests, cinema, sports, something like this. And I think it will be very interesting.
Yes, thank you.
I was thinking, yes, we have data on extracurricular activities. It's been not as good in the first module because only 2 or 3 months spent together, and maybe not anyone knows about possible activities in the university. But I think in the end of year we have questions on
yes, we have a question about participating and sharing some student societies in universities, some clubs and so on. Maybe it would be useful.
No more questions. All right. Thank you very much.
Thank you.